Every concert grand begins with carefully aged Sitka spruce, selected not just for strength, but for perfect moisture content. Each cut is made by hand against a precision fence, because one crooked billet can ruin an entire soundboard. A perfect glue joint starts here, dead flat, no gaps, no guesswork. Uniform thickness is critical because the soundboard must flex as one living diaphragm. They're not just gluing wood, they're tuning how the entire piano will breathe. Humidity control isn't optional. Wood moves, and that movement must be predicted, not repaired. Every rebate and radius is machined to within fractions of a millimeter, because tone leaves no room for approximation. The ribs don't just stiffen the board, they pre-shape the crown that makes the piano sing. Pressure must be even across every rib. Too much here, too little there, and the crown goes out of tune before a single string is pulled. Patience is part of the build. If you rush the cure, the piano pays for it for decades. The rim is the piano's skeleton. Bend it wrong now, and the whole instrument fights itself forever. They're not just bending wood, they're locking in the piano's acoustic geometry for the next 100 years. Even at this stage, the team treats every surface like it will be visible under stage lights. These ledges and joints have to be perfect, because the case is part of the instrument's acoustic filter. A grand piano's case isn't a box, it's a tuned resonant structure, and every joint either helps or hurts the tone. If the bed isn't perfectly true, the plate won't seat, the strings won't align, and the piano never holds tune. The plate carries over 20 tons of string tension, so we inspect it like a bridge component, not a piano part. A burr here can chew a string, snap a pin, or ruin tuning stability, so we finish every hole by hand check. The seal coat doesn't change the tone, but it absolutely determines whether the plate outlasts the pianist. If the plate rocks even a hair, string angles shift, and the piano will never settle. We don't guess flatness, we machine it, prove it, then never touch it again. Torque pattern matters as much as torque value, because tension must travel through the case, not twist it. The pin block is where tuning lives or dies. If it crushes, the piano never stays true. Each hole is drilled at a calculated angle, so the tuning pin wedges itself in, not just bites. If the fit is off by a fraction, the piano will slip in the middle of a concert, and you can't tune around that. The pin block must locate exactly under the plate, because string geometry is measured in millimeters and cents. The bridge is the messenger. It has to carry string vibration to the soundboard without coloring the truth. Scaling isn't a number on paper, it's the roadmap that makes bass deep, treble clear, and everything in between sing in tune. If the bridge rocks, the soundboard can't transfer energy evenly, and you'll hear it as wolf tones and dead notes. These spruce ribs strengthen the soundboard while preserving its flexibility. Their curved shape helps the piano project sound across large concert halls. After curing, every rib joint is inspected by hand. Even small glue irregularities can affect vibration transfer. The outer contour must match the piano rim exactly. CNC routing provides consistency while craftsmen verify every curve manually. The bridges transfer string vibration directly into the soundboard. Their position determines tone balance across the keyboard. Each bridge notch guides a specific string angle and pressure point. Accuracy here directly affects tuning stability and sustain. Before assembly, technicians test the soundboard's natural resonance by ear. Subtle differences in tone guide the final finishing adjustments. The cast iron plate supports nearly 20 tons of string tension. Each plate begins as molten iron poured into massive sand molds. After cooling, the raw casting is separated from the mold. Every surface is inspected for cracks, voids, or structural defects. Grinding removes excess metal left from the casting process. Smooth surfaces prevent stress points once the strings are installed. Computer-controlled machining creates perfectly flat mounting surfaces. Even tiny inaccuracies could affect tuning stability. These holes anchor the piano strings under extreme tension. Their alignment must remain accurate across the entire frame. Before finishing, technicians inspect every critical surface by hand. Minor flaws are corrected long before assembly begins. The protective primer seals the iron surface and prepares it for decorative finishing. Even coverage prevents corrosion over decades of use. The gold finish protects the plate while giving concert grands their recognizable appearance. Multiple coats create a durable surface. Controlled heat curing strengthens the finish and prevents future cracking. The process can take several hours for complete stabilization. Agrafs and hitch pins guide the strings across the plate. Their spacing affects both tone clarity and tuning precision. With machining and finishing complete, the plate is ready to join the piano's wooden structure. Precision handling prevents even minor distortion. This is one of the most delicate stages in piano manufacturing. The iron plate must align perfectly with the soundboard and rim beneath it. The pin block anchors every tuning pin in the piano. Its laminated maple construction resists enormous string tension over decades of use. The pin block must fit tightly against the iron plate and wooden rim. Even slight movement could compromise tuning stability. Before permanent fastening, technicians verify the geometry of the entire structure. Precise alignment ensures even string pressure later in assembly. Structural fasteners are tightened in a controlled sequence to distribute stress evenly throughout the piano frame. Each piano key begins as a carefully dimensioned maple blank. Consistency here affects the feel of the entire keyboard. The front profile of every key is shaped by hand for comfort and consistency during performance. Lead weights adjust the touch and response of each key. Tiny variations are corrected one key at a time. The keyboard surface combines durability with tactile precision. Alignment must remain perfectly straight across all 88 keys. Felt bushings reduce friction and noise inside the keyboard mechanism. Proper fitting allows smooth and responsive movement. The keyboard becomes the performer's connection to the piano. Every key must move evenly before the action system is installed. The hammer felt determines much of the piano's tonal character. Density and shape directly influence brightness and dynamic range. Each hammer assembly must strike the strings at an exact angle. Small alignment errors can alter tone and touch response. The action mechanism translates finger movement into hammer motion. Thousands of moving parts must work together smoothly. The completed hammer assembly is carefully integrated with the keyboard. Every key must trigger identical mechanical movement. Escapement allows the hammer to release before striking the strings. Proper regulation creates responsive repetition for fast passages. Each hammer must strike its assigned strings evenly. Precise spacing prevents uneven tone and unwanted vibration. Hammer shaping refines the contact surface that strikes the strings. Even subtle changes affect tonal clarity. Voicing adjusts the density of the hammer felt, shaping the instrument's final tonal character. Concert grand actions are designed for rapid repetition. Regulation ensures consistent response during demanding performances. Bass strings use copper winding to increase mass without excessive stiffness. Their construction produces the piano's deep resonant tones. Each string follows a carefully calculated path across the frame. Precise positioning affects sustain and tonal balance. Tuning pins grip the laminated maple pin block with tremendous force, holding the strings under constant tension. The strings are tensioned slowly over multiple stages. Sudden stress could damage both the soundboard and iron plate. As tension increases, the entire piano structure begins to settle into equilibrium. Multiple tuning passes are required. As tension increases, the entire piano structure begins to settle into equilibrium. Multiple tuning passes are required. Dampers stop the strings from vibrating after each note. Their timing and alignment affect clarity throughout the instrument. The pedal system controls several internal mechanisms simultaneously. Smooth movement is essential for expressive performance. Proper damper lift ensures notes sustain evenly across the keyboard. Small inconsistencies are corrected by hand. The cabinet finish protects the wood while creating the piano's mirror-like appearance. Multiple coats are applied gradually. Controlled curing hardens the lacquer evenly, preventing future cracking or surface distortion. Wet sanding removes microscopic imperfections from the lacquer surface, preparing it for high-gloss polishing. Polishing creates the signature concert grand finish, revealing the depth and clarity of the lacquer. The lid projects sound outward toward the audience. Its fit and alignment also protect the instrument's finish. Exterior components must move smoothly while matching the precision of the instrument's internal mechanisms. Tuning a concert grand requires both electronic precision and experienced listening. The instrument continues settling under tension. The keyboard must respond evenly from the softest touch to full concert dynamics. Acoustic testing confirms the soundboard, strings, and frame are vibrating together as a unified system. Before shipping, every visible surface is inspected under intense lighting for even the smallest cosmetic imperfections. Concert grands require extensive protection during transportation. Even minor impacts can affect regulation and finish quality. The completed piano is stabilized inside a reinforced crate designed to absorb vibration during shipping. After leaving the factory, the instrument is prepared for its first performance environment. Temperature and humidity changes during transport require a final tuning before performance. From raw lumber and molten iron to a finished concert instrument, every stage of craftsmanship shapes the voice of the grand piano. Inside the piano, thousands of precisely regulated movements occur every second during performance. The keyboard translates subtle finger pressure into a wide dynamic range, from delicate pianissimo to full concert volume. The sustain pedal releases every damper at once, allowing the strings to resonate together throughout the instrument. The soundboard amplifies string vibration into the rich tone heard throughout the concert hall. In the treble register, precise string scaling and hammer shaping produce clarity and brilliance. The final instrument combines structural engineering, acoustic science, and traditional craftsmanship. Every stage of construction contributes to the piano's final voice, long before the first note is played. The rim forms the structural backbone of the grand piano, resisting immense string tension. The cast iron plate provides the strength needed to support nearly 20 tons of string tension. Modern CNC machining ensures the plate fits the piano structure with extreme accuracy. Balancing the keys creates a consistent touch across the entire keyboard. Voicing shapes the personality of the instrument by refining how the hammers contact the strings. String installation transforms the piano from a mechanical structure into a musical instrument. Concert tuning requires repeated fine adjustments as the instrument settles under full tension. Every concert grand undergoes detailed visual inspection before leaving the factory. After months of manufacturing and regulation, the instrument is finally ready for performance. The finished concert grand reveals the combined result of engineering precision and handcrafted artistry. Every mechanical adjustment inside the piano contributes to its responsiveness and tonal depth. The voice of the concert grand carries the work of every craftsman involved in its creation. From raw materials to concert performance, each stage shapes the identity of the finished instrument. Built through precision, patience, and craftsmanship, the concert grand piano remains one of the world's most complex musical machines. Inside every concert grand piano is a balance of industrial engineering and human craftsmanship, refined through hundreds of precise manufacturing steps.